staff rather than a sort of programming staff, you're often like as a network manager or somebody working in the network sort of admin for it. There's all sorts of questions about how new applications are purchased, how they're rolled out to it. You notice here that we're still running something like Windows 7 or whatever, something like that on our desktop machines for it rather than Windows 10. Some of the reasons for that is they just take either too long to roll out for it. There might be sort of problems in rolling them out. They may not be compatible with other pieces of software. We've got a huge range of software that we're trying to run on in these labs for us. And you've got to make sure that all the individual items of software are compatible with the operating system. Somebody somewhere has got to make the decision on buying these. Now, admittedly, we get them with a sort of like an educational license, or they're there for a discount and the like. But when you're rolling it out across, say, a company organisation, you've got 1,000 PCs perhaps that you're trying to roll these things out on. It's not just the same as nipping down to PC World, picking up a PC, unboxing it, and then sort of getting your Windows disk out and installing your Office and your Eclipse and all the other things that you might sort of want on it. You know yourself how long that takes for your own sort of individual machines. If you had to sort of start from scratch on your laptop, something, it's going to take you a good part of a day to get everything up and running really on it. Through from walking out first thing, say in the morning, to buying your new laptop, through to the end of the day when you can actually get some of your university demos up and running on it. We've also got to sort of actually buy these server machines, plan the network capacity for it. And as I say, when you're talking about, certainly here at MMU, thousands and thousands of machines across the university, whether it's in the second or third floor of the computer block where we've got the specialised computing ones, the lower floors where it's more sort of generic ones, things like in the library where we've got some, like in the library where you've got sort of, again, sort of more general ones, but they might have specialised sort of areas for some. Somebody's got to make the decision over buying those, somebody's got to actually sort of implement them, and it takes a huge amount of time to do that sort of thing. For example, for the machine images that we're having in the labs, we were asked back in April this year to decide what we want on those images and trying to predict, I mean, if we wanted it in April, we'd have to start predicting around about March what we would need up until next May. And particularly in some areas of computing, things change really fast. You get new versions of software coming out. You can see there that we're running Eclipse Neon, say, in the labs. That was a thing that was available at the time, back in March. Later versions have come out. So all, in terms of sort of getting things up and running, these sort of questions are just solved and asked over and over again in sort of slightly different ways. And they can take forever to roll out for people to make a decision on it. If I want a piece of software put in on my desktop machine, which I don't have admin privileges to, I have to sort of put in a request, and 6 weeks later I might get it. Whereas if it's your own machine, your own piece of software on it, you can just either download and get it, or to buy it, depending on what sort of type of software it is. And so where the sort of cloud idea is, and that you're hopefully mostly aware of, is to try and eliminate some of these problems for it. To be all sorts of scalable is one of the sort of key phrases for cloud computing. To make things scalable, to handle large variations in workload. Workload in terms of the number of users getting onto a network. Does it make a difference whether there's 10 users on the network or 2,000 users on the network? Can your network servers cope with that? Now, again, something that you might have experienced yourself, and if you're living in a shared house and you're having something like a network drive that you might share between people, or an internet connection, you know that if you've got one internet connection in the house and 20 people, that's a bit of an exaggeration perhaps in a house, but party going on, or there's sort of 8 people living in a house, that's not sort of unusual. The bandwidth problem that you might sort of get to sort of people downloading in it, or using a shared network drive. Again, sort of multiple people trying to access that. As soon as you start using BitTorrent or something like that, and that really grabs all the resources. There's a big sort of variation in workload, and yeah, it would be nice if you could have some massive great server that's running plenty of memory, a nice sort of network attached storage that again can sort of cope with that sort of thing for it, where you start building up perhaps your own version of a network, just even in your own sort of household. We're not really looking at the sort of household situation, we're looking at big scale ones for it, where we can add extra hardware and remove without any sort of human intervention. So we can just say, look, this workload seems to have really been increased today. Can we not sort of auto add some servers to this to deal with that extra thing coming in, and then when that need dies away to decommission them automatically. So that, in terms of the resources, your hardware, services, storage capacity, networks, all these sorts of things that perhaps might need to grow for a session and then shrink back again for it, or new applications. So basically have this, what seems like an infinite pool of resources to dig into is a sort of aim to it. All based on virtualization technology, which has been around for a long time. But we're just sort of spreading it out now to make things a lot easier in that network situation, to be able to share your resources a lot better, and to do it sort of immediately. So the components that are sort of typically put together in this, we will have our sort of standard clients for it, and some distributed servers which are sending out those applications. We'll also have some data centers for it, but instead of it all being on one PC, as you say, hopefully recognise from the idea of the cloud, we're now distributing them around, making it rather than just over a local network, making it over the sort of internet. And it's only really become possible with the advent of fast broadband. So if we didn't have fast broadband, the whole bit about the cloud just couldn't work. It would be so slow for it. It would just sort of crawl along, and nobody would want to sort of use it. So our clients in this case, they are our end users, interacting. Those who want to interact with an application to get their job done. Either through a thick client, where they've got the actual application on their machine and the data might reside somewhere else. A thin client, which is the browser sort of type applications, nothing's installed on the actual machine. The application that you want just dragged across into the browser, so there's nothing really there to install in the first place. They did have a try at using those with computers with no hard drive, just for sort of display only. That's the idea of some of the Chromebooks and things. Hasn't really sort of caught on. People are still a bit wary about not actually having their data on their machine or their software on their machine. And then, yeah, mobile clients using it, and those sort of things have sort of blurred together really, whether it's using your smartphone or a tablet to get in there. They're all sort of blurring a bit really with the general sort of laptop approach. The servers are then geographically distributed, but you don't necessarily know or need to know where they are. Now we've got them, again, sort of on our own network, just within the university. We've got our own servers that you attach across to. Yes, you use the Mudfoot database, for example. You link into that, but that's just our own sort of server to sort of access. We know where it is. We know exactly which operating system it's running, what software is running on it. The idea of truly distributed is to put them in different geographical locations altogether in a place that's more convenient to the supplier of that sort of service for it. Responsible for, as well as the actual sort of data place, all the archiving backups that might go. And then together with this, you've got the data centers as well. Now the acronyms that go along with this, and you'll see these sort of things cropping up all over the place, and a few more have come into it. These were the first sort of three around, but they've also introduced new terminology for this. Software as a service is a thing that the public sees, where you're selling access to your software, either free or at some sort of renting it to some sort of level, through to platform as a service, where you're offering development for software developers. So you'll offer them a platform on Linux or a platform on Windows with a certain sort of database attached with it. You get a database operating system, one of these sort of stacks, as they sort of refer to. And then the infrastructure as a service, which we'll look at in our sort of final week, where you're offering whole pieces of hardware to rent out, whether that's PCs running different sort of operating system, databases, networks, again, the sort of whole bit of that sort of hardware for it. And we can sort of bring these things down a bit more for it. But in terms of where some of these might live for it, the different sort of types of things, applications, your data, your operating system, your servers, your storage or whatever. If you're talking about, say, software as a service, everything is off-site for it.